All right, so elements becoming ions is very important in chemistry, and different elements or different atoms have different charges or can have different charges. So we'll just say different elements can have different charges, right? And the good thing for us is that we don't really need to memorize a whole lot because the periodic table organizes it all for us. So I've got a little periodic table here. And then I'll also draw my outline in case you're writing this in a notebook where you might not have access to copy and paste, right? So you can just draw a crude outline of the periodic table, and it's something good that you should be able to do. So first off, all the way left, right, we've got hydrogen, lithium, sodium, potassium, and so on and so forth. This is what's known as our group 1 elements. They're also known as the alkali metals. And they're always going to have a charge of +1, right? They're either going to be neutral or they're going to be +1. That's really the only ion they can form. Next up, we've got our group 2. This one contains, right, our beryllium, magnesium, calcium, so on and so forth. This is, right, group 2, known as the alkali earth metals. And they always have a charge of +2. Next up, we've got this big block down here. That's our transition metals. We'll touch on the periodic table a little bit later. We're just going to ignore the transition metals for now. They can have all types of charges. Then after that, we've got our group 3, right, which contains our boron, although boron's a little bit weird. It's mostly just talking about aluminum and gallium here. And they're going to have charges of +3, right? So +1, +2, and then +3. Right, so that's group 3. Note that in numbering, we also skip the transition metals. That's just called the boron group. It doesn't get a cool name. They're +3. Next up, we've got our group with carbon and silicon. These guys can behave quite differently. Generally, they're either plus or -4, but they can actually have a whole bunch of different charges. So there's not really anything kind of too useful there. Next up, we've got our group with nitrogen and phosphorus, and so on and so forth. That's our group 5. These are called the Nictogens, but there's a silent P there. So, you know, English language, there you go. Nictogens, just don't pronounce the P. They almost always have a charge of -3, at least in ionic compounds, which we'll learn about later. After that, we've got the group with oxygen, sulfur, and so on and so forth. Made this periodic table a little bit too small. Let's go ahead, just redraw it a little bit. There we go. Let's see, that one was -3. As you might be able to predict, these are now going to be -2. So that's our group 6 elements. Those are known as the chalcogens. And they have a -2 charge. After that, we've got our halogens. So that's our kind of fluorine, chlorine, bromine, iodine, and so on and so forth. They almost always have a charge of -1. So that's group 7, halogens, -1. And then finally, we've got this last group right here, group 8, with our helium, neon, argon, so on and so forth. And these generally are neutral. They generally do not have a charge. They're very unreactive. These are what are known as our noble gases, right? So they're noble, so they don't like to interact with other people. They like to just kind of do their own thing. And they generally do not get a charge whatsoever. So you can see the periodic table is organized for us very nicely. And that's the reason the periodic table was made this way, right? They observed things and then they aligned in this periodic table according to their observations. Later on, so that's kind of the what, right? They just made some observations and then they made this chart. Later on, we'll learn about the why behind it. But for now, just be able to use the periodic table to identify common charges of the elements, depending on which group they're in.